All right, folks, so welcome to another episode of Ape Answers. In this episode, number 22, we're going to talk a little bit about RF noise interference. Now, a lot of people talk about antennas being more noisy than other antennas. Specifically, they say that vertical antennas are noisier than horizontal antennas. Somewhere in the middle, we have sloper type antennas like end-fed half waves or random wire antennas. Now, there's a reason that this man-made noise causes a little bit of interference, and in this video, we're going to talk about why that is. Why do makers and engineers around the world choose PCBWay.com? Because PCBWay.com combines high-quality PCB manufacturing, expert assembly services, and outstanding value in one place. Add fast production, dependable global shipping, and dedicated customer support, and you have a partner you can trust. No matter the size of your project, PCBWay.com is ready to help you build it. Visit PCBWay.com and get started today. So I made a video on vertical antenna radials, comparing elevated to ground radials. And our question was posted there. It comes from BDuff5004. And he says, great video, TheSmokinApe. Would you consider a video explaining why background noise is mostly vertically polarized? I have read and heard this many times, but I think most man-made noise is physically horizontal. Power lines, data cables, house wiring, electric fences, etc. And I said, hey, BDuff, I can put it on the list. So just remember, when you ask a question, it may end up in an Ape Answers video. So when hams say that HF noise is vertically polarized, they're usually describing a practical observation rather than a strict law of physics. It basically means that local man-made interference is much better at finding its way into vertical antennas than horizontal antennas. It isn't that all noise in the air is vertical. It's that vertical antennas are much more efficient at collecting this specific local energy. Most of this electric smog in a neighborhood comes from everyday items, switching power supplies, LED lights, solar inverters, computers, stuff like that. These devices are connected to wiring, like utility poles, house wiring, service drops. This often has a significant vertical orientation. This wiring acts like small transmitting antennas, and they radiate noise with strong vertical components. Vertical antennas are particularly vulnerable because they are designed to respond to those vertical electric fields. Further, because many of these antennas are ground-mounted, they are sitting right in the middle of where this noise propagates, along ground systems and utility lines. And this is why vertical antennas often show much higher noise floors, sometimes reading as high as an S7, while a dipole that you might have close by sits at an S4. Horizontal antennas like dipoles or loops have a natural advantage because they reject that portion of vertically oriented ground noise. They're also typically mounted higher up, which physically separates them from ground level interference. Even if a distant signal is slightly weaker on a dipole, the signal-to-noise ratio usually is much better because the noise floor has dropped so significantly. And we're going to talk about that in more detail. So you might worry that horizontal antennas will miss out on some signals, but the ionosphere actually helps us out there. By the time distant signals, like a DX signal, reaches you, it has been scrambled by the ionosphere. It arrives as a mix of horizontal, vertical, and circular waves. And this is why a lot of serious operators use a vertical antenna for transmitting to get that low takeoff angle. And they switch to a horizontal antenna, like a loop on the ground or a loop or a dipole, so they can actually hear signals above the local noise. So here's just a quick comparison that I put together, and it talks about antenna types, noise floor intensity, and the primary mechanism for the noise. So when we take a look at a ground-mounted vertical, that is the highest. So that is the most susceptible to noise floor increasing. And this is because it couples with that maximum load, all of that electric smog that I talked about earlier in the environment generated from all those devices like computers and switching power supplies and such. And we take a look at end-fed half-wave and random wire antennas. These are both end-fed wire antennas, and they're typically mounted in a sloper configuration, meaning that the transformer is closer to the ground and the end of the antenna is typically mounted up in a tree or a mast or something like that. So it's usually at somewhere around a 45 to 60 degree angle, and this kind of puts it close to a vertical. And we're going to call the noise floor intensity here moderate to high. And that's because they still pick up a significant amount of that electronic smog. It has a vertical to ground component. Now, when we take a look at a horizontal dipole, the noise that they pick up is lower. And this is because we have physical separation. Typically, dipoles are mounted a half wavelength above ground, above that electronic smog that we were talking about. Now, horizontal loops typically have the lowest impact to noise floor. And that's because they actually reject a lot of that vertically oriented man-made noise. So here's the important slide in this conversation. So when we take a look at signal strength and then we take a look at the noise floor, we're comparing a 40 meter quarter wave vertical to a 40 meter dipole at 40 feet. And so when we take a look at these, our signal coming in on the vertical, let's call it an S9 signal, but we have an S7 noise floor. That gives us a really small dynamic range, which is the difference between the strongest signal that we're measuring and the noise floor, being 2 S units. Now, if you take a look at that same signal coming in on the 40 meter dipole, maybe the signal's a little weaker at an S8, but we have an S4 noise floor. So we have a bigger gap there. We actually have 4 S units of signal in our dynamic range, and that makes a huge difference. And that's really it, folks. It's a pretty simple thing to figure out. Most of this noise creates this big electric cloud or electric smog sitting at ground level, and vertical or vertical-esque antennas generally tend to pick that up a little bit easier than horizontals. Anyhow, that's going to wrap up this video. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. As always, thank you for watching.